Ion might be a term you've heard in your day-to-day life, whether it be in the context of watching sci-fi movies, where they may have been using ion torpedoes.
Ion torpedoes away!
Or in your high school classroom, right as you're falling back asleep at the start of a Monday morning. Either way, you're here because you might be wondering, what exactly is an ion, and can they actually be useful? Or are they just the subject matter of fictitious sci-fi movies? Well, let's find out. To understand ions, we first need to understand the conditions which lead to their creation. Main group elements, denoted by A next to the group number, want an octet of electrons in their outer shell, with the exception of hydrogen, helium, and lithium, which want 2 electrons in their outer shell. And that's because an octet is the most stable configuration of electrons, with the least amount of repulsion between electrons. Atoms are capable of transferring electrons between each other to achieve a fully occupied stable outer shell. In this process, they become either positively or negatively charged, dependent on if they have given or received electrons. Once an atom has a charge, it is then referred to as an ion. This can be further subdivided into 2 types of ions, being cations and anions. If an atom has given an electron or multiple electrons and become positively charged, it is referred to as a cation. Contrastingly, if an atom has received electrons and become negatively charged, then it's an anion. So how do we name ions? Well, cations, which are typically metal ions and lose electrons, can lose 1 or multiple electrons. If they only have one charge state, meaning that they always lose the same number of electrons, their name would be the metal atomic name, plus the word ion at the end of it. So some examples of this would be lithium ion, sodium ion, or calcium ion. On the other hand, if they have various charge states, meaning that they can give a varying number of electrons based on the conditions, and this is usually reserved for transition metals, then their name would be the metal atomic name, followed by some Roman numerals corresponding with the charge state. Some examples of this would be Fe2 or Fe3, or Pb2 or Pb4. Anions are named a bit differently. For monoatomic anions, just add the suffix "ide" to the end. So for example, chlorine, when you add another electron to it, it becomes chloride. Polyatomic ions are again named a bit differently. Polyatomic ions are composed of more than one type of atom, and are tightly bound together. A vast majority of polyatomic ions are anions, and very often these anions contain oxygen. Oxygen-containing polyatomic anions are oxyanions. Oxyanions are given the suffix of either "ite" or "ate", dependent on how many oxygens are attached to the molecule. If an oxyanion has few oxygens attached to it, it might get the "ite" suffix. Whereas if it has many oxygens, it's more likely to get the "ate" suffix. So some examples of this might be hypochlorite or chlorate. The table on the right here shows various polyatomic ions and their net charge. Some of the most important ones to memorize here are ammonium, phosphate, carbonate, hypochlorite, hydroxide, cyanide, and acetate. So, what are the uses of ions? Well, ions are critically important, and possibly even more important than what the Rebel Alliance are using them for. For example, our brains are constantly using ions to cause action potentials to fire in our neurons, and that gives the foundation for the electrical signaling in our brains and bodies. Another example of how ions are used are in mass spectrometers, where ions are separated based on mass to charge ratios, and that allows us to qualify and quantify what substances are. I want to say a big thanks for watching episode 2. If you enjoyed or got something useful out of this, please consider subscribing. It would really help out. Once again, my name's Roeger. If you have any comments or questions, please leave them down below. Thank you.